Okay, so the question is, a toy tractor sold for $265 in 1978 and was sold again in 1985 for $485. Assume that the growth in the value V of the collector's item was exponential. So since this problem gives us that last line, we can assume that the equation P0 e to the kt equals P of t is what we will need to solve this. So P0 is population or value at time 0, E is a number, K is the growth rate, T is time, and P of t is the value at some time in the future. We're also told in this question that P0 or V0 equals 265. So, in order for us to use this formula, we'll plug in the things we know, and I'll use V instead of P because that's how it's worded to us in the problem. V of t equals 265 E to the kt. So, we are asked to find the value of k. How quickly is this thing growing? And in order for us to find k, we would have to know V of t, some future value of this collector's item, and then we also have to know t, how long it took to grow to the future value that we're using. And we're given those things in the problem as well, although they are a little hidden. So one of the things that we know in the problem is that in 1985, it raised to a price of $485. So go ahead and make your future value that was known $485. The initial value was 265. We're looking for K, and we're also supposed to know T. How long did it take for the value to increase from 265 to 485? And we know that as well because in 1978 it was $485, and in 1985 it was $485. So it took us approximately 7 years for it to grow to that value. So T is 7. Now we have everything we need to be able to solve for K. It's our only unknown in the equation. So let's start by getting rid of 265. It's being multiplied with E to the 7th K. So we're going to divide by 265 on both sides. Get my calculator here. 485 divided by 265. So over here on the left side we have 1.8301888679 equals E to the 7K, and since it's a multiplication up here on the top, I can write that as K times 7 or 7 times K. Next, to get this exponent out of the exponent, because that's where our unknown is, we have to use a logarithm. And anytime we see this E, we'll know that we use the natural log because it has base E. So we'll do natural log of this number over here on the left, 1.8301888679 equals the exponent from this exponential equation. So in your calculator, what I want you to do is use the ln button and use the button second and this negative sign. So what that will do is it'll put the entire decimal that you have in here. You don't have to retype it, and this number is technically rounded. Your calculator will only hold a number to 10 digits. So do natural log of second answer. Like I said, it's just pulling in that number right there, and hit enter. So now we have 0.604419065 equals 7K. Alright, and your calculator just hit divide and 7, and it tells you that K is equal to 0.08634. And you're asked to round to the nearest thousandth, so 3 decimal places, 0.086. Let's let's go ahead and work through the rest of this problem. Part B asks you to find the exponential growth function in terms of t, where t is the number of years since 1978. So part B doesn't ask you to solve for anything, just write an equation with the information that you're given. So v of t now equals that starting value, 265, e to the 0.086 t. So we're writing it in terms of t, and what we have is some generic formula that we could use to create any, or to find any value after any time that we wanted. Part C says estimate the value of the toy car. Estimate the value of the toy car in 2003. So now they've given us a time of 2013. Now they've given us a time of 2013. So if 1978 is our original time, or our starting time, what value is 2013 from 1978? So do 2013 minus 1978, and it tells us that t is equal to 35. So that equation that you just made in part B, for part C, we're going to plug in that value. What is the value in 35 years from the original start year? So let's plug that in. In your calculator, you have to make sure that when you put this e here, that you tell it all of that belongs in the exponent. So when we open up that set of parentheses in our calculator, we got to make sure it all goes up there. So for part C, we're doing 265. Our E button's over here on the left side. So second ln brings up that E, 0.086 times 35. And we get that it was worth $5,376.16. The last question asks, question D, the fourth part of this question says, what is the doubling time for the value of the toy tractor to the nearest tenth of the year? So we're looking for time. What is the doubling time for the value of this toy tractor? So how long does it take for it to double in value? So first, or one method for doing this, we can take our original value, 265, and we can double it. So how long does it take for this thing to increase to $530? So that is our future value in our v of t equals v e to the kt formula. So our future value, we want to know how long it takes to get to $530. When it initially started at $265, and it's growing at a rate of 0.086. How long did it take? So we need that t in there. So just like we did when we solved for k, we're going to divide both sides by 265. This should give us 2 equals e to the 0.086 t. I knew this was going to be a t because I doubled this value to get to the 530. Again, this is an exponential function where I have an unknown in the exponent. So to take my unknown out of the exponent, I'm going to use a natural log because this is a base e exponential. So natural log of the thing over here on the left, which is a 2, equals 0.086 t. In your calculator, you're going to do natural log 2, enter. So that's the number over here on the left, 0.6931 equals 0.086 t, and divide both sides by 0.086, and you get t equals 8.05985. And your question asks you to round to the nearest tenth of a year, so one decimal place. T is equal to 8.1 years. the last part of this question, E says, find the amount of time after which the value of the toy tractor will be $5,921. And we're asking for how long from this original $265 at a growth rate of 0.086. How long? So we're looking for T. So start by dividing everything by 265. So we have 5921 divided by 265. This gives us 22.3433963 equals e to the 0.086t. Turn this into a logarithm to get that unknown variable out of the exponent. In your calculator, you're going to do the natural log of that number you just found. So just hit second and the negative sign. It'll bring up that value for you. You don't have to type it in. Hit enter, and then you're going to divide both sides of this equation by 0.086. So you get T equals 36.12245,124. It asks you to round to the nearest tenth of the year. So this is 36.1 years.